Hello everybody, today we're going to be making a house price prediction. So for the imports we're going to need pandas, PD, we can need Seaborn, SNS, import, and we also need XGBoost. Seaborn, oops. Okay, there we go. So the first thing that we want to do is get the data. In our previous post on our website, we showed how to do it, but just in case, we can I can show you. We're gonna need a few different things though. We're gonna need to go to your profile account, and we can see we can create a new API token. If you click it, a file should pop up, and it should give you something like this where you can copy and paste this. And then we also are going to need the data itself. So we can do Kaggle. Actually, this thing should be here. Control-C. Range, oops. Okay, you can see it's downloading. We can check. Yep, it downloaded. So now we can move on to our data exploration part. So let's check out the chain, and let's have pandas read it so we can work with it more easily. Let's get the this thing requires the path. You can just copy path, put quotations. Okay. Now that ends successfully, we can do chain.shape. Oops. Chain.shape. From this we can tell that there's almost 1500 rows and 81 feature columns. Let's see what the columns look like. So the head prints as the first 5 rows, but we can see all the columns. ID, subclassing, so on and so on. And we can see that a lot of it, for some of the columns, there's a few missing values. This is displayed by the NaN. Let's see how many missing values there are. The first way we could do this is through doing something like this. .sum to CSV, and then this is the name of our file. So what this basically does is it makes us a file that we can view over here and see all the missing values. Let's run this and refresh. So we can see chain nulls has appeared. It's the same name. Okay. So we can see that lot frontage has 259 missing, some over here, and some for fireplace. Oh, and misc feature has a lot. Miscellaneous features, I'm guessing. We can also visualize this more better by doing this. Y typical goes false. We can also get rid of this. See by false. Okay, so we can see that lot frontage has a lot of missing values. So does alleys. Oh, and pool QC, I can't tell if the miscellaneous value is connected. It's a bit hard to see. That is why we have a file. You can see that miscellaneous feature does indeed have a lot missing. And alley, yeah, alley also has a ton of missing values. Okay, so when dealing with missing values, there's a few options we can do. We have a few options. We can either, for the numerical values, we could put in the mean, and for categorical values, we can pass in a new answer as in none, and that could be a category instead of a missing value. So obviously the first step is going to be to find out which ones are categorical, which is are numerical. We can see that all the object ones, we can check back up here. Street. So this should be categorical, however it's recognized as object. That is something we need to fix later on. But other than that, it gives us information. So for example, the first one we can fix was lot frontage. So we can do lot frontage equal train none fill NA. So this thing fills in the missing values with we can do for this one the mean, since this was numerical, I believe. Lot frontage, yep, float 64. So we can just set in as the frontage. Okay. Things should be fine. And then for example, the MS zoning also had, MS zoning did not. Okay, we can go next to alley. Alley was an object type. So for alley, we can do alley and then for this one we can pass in a new value, categorical value, and will be recognized the same, and this thing can be placed in for the missing values. Ideally this should work, and it does work well, because these are just categorical values, and having none is just another type of value, and that's what the model reads anyway. So now we can see the where is it? Let's check pool QC. So wow, pool QC has a lot, and so on. We can fill in each miscellaneous feature, fence, fireplace, and for the ID we can totally just drop the whole thing since it's not related. ID. Do not worry about that access for now. This should be it. For example, now let's check if this thing actually worked. We can check all the unique values of alley. Train alley dot unique. Yep, none was passed in. So now let's check our heat map. Can use the same one. Yeah, you can see that most of them have just cleared out. Okay, so now these are just a few values, and in order to get rid of them, we can just drop them the row completely instead of the column. Drop NA in place. True. Okay. Now that is done, we can check the train shape. we can see that this has cost us a few rows, 1460. But I think that should be fine. There's still plenty of data values. Check the heat map again. See, completely empty. No missing values. So now what we have to do is, if you recall, we have object values and these need to be categorical, so we can do one hot encoding on them later. So let's just cycle through all of them and see how many we changed. Chain.columns. What chains.columns will give us, columns, give us all this, so it'll be cycling through this, and then if chain I dot d type equals an object type, then that specific value should be changed into an as type of category. This should be in quotations, and then we can print found for every time found, and of course we should, and in the end we can check how many. Range from object type to category, and that should be good. Okay, so 43 columns were changed. Now if we check out the chain.info once again, these are all categories, from object to categories. Okay, that's pretty good. So now, once we have changed everything, we should be able to now proceed and make the categorical values into one hot encoding. So we can just categorical columns, and from earlier we can get these ones. We do that. Okay. Now we have this. Now let's check out for I in columns chain. Now we can switch it to cat coding. Cat.codes, and now let's visualize it and our head. Invalid syntax. Okay. So Ali, which used to this I'm pretty sure these used to say pave, I've now been converted to 1, and it should be similar for everything else. For example, if it was paved, it might be 1, and unpaved might be 0. So now we can get the X chain, and basically the X chain will be every column except the sales price. So we can do X equals chain. This, we can copy this. And simply our Y, which we're trying to predict, is the sale price. Spelling. Okay, so the classifier is very simple. For this one, I found that XGBoost was really good at for this type of problem. Regressor, and to make the model, we can easily just dot fit and the X, and we can pass in the Y. Okay, so now let's see how good our model did. Alright. So for this one, we use R-square to determine how good our model has done. How much of the data can be explained through the model for this example. 0.3f. I can just do this. Classifier. And now let's get the score. X and Y. Where did we mess up? Okay, so 0.963, that is a very good value for our model. That means it predicts like 97% of the data of the price for say. It takes all this into consideration, and it's like 96.3% of the time correct. Or not correct, but like it explains it, the reasoning behind it. In the next video and post, we will be going over how we can make a web UI so that you can put in your own data and estimate how much your own house could be worth for. Until then, thank you very much.